Hello viewers, welcome to this exciting video. In this video, we will be looking at the GCE Science Paper 1 2021 exam. Section B, question B1. Question B1 reads, Figure B1.1 is a diagram showing the reading of the vernier calipers. Figure B1.1 is a diagram showing the reading of the vernier calipers. So we have a vernier calipers there, and question A is, what is the reading shown on the vernier calipers? What is the reading shown on the vernier calipers? So taking readings from a vernier calipers is relatively easy. However, sometimes we get entangled in the process and make very small mistakes that are usually costly. I would try to give as much information as possible in taking these readings and certain precautions that we need to take when taking readings. All right. So when taking readings from a vernier calipers, what we need to do first is identify which one is the main scale and which one is the vernier scale. So we need to identify which one is the main scale and which one is the vernier scale. All right. So the main scale usually has big numbers. For example, it may have numbers ranging from, let's say, 0 up to, let's say, 15. Okay. So it may start from 0. You'll see numbers like 1, 2, 3, 4, 5, 6, 7, up to maybe 15. While on the vernier scale and on the main scale, you have a good number of markings. Okay, there will be a lot of markings. However, on the vernier scale, you only expect to see about 10 markings. And these markings will usually range from 0 to 10. They will usually range from 0 to 10. And it's usually small. So we check for those. Okay, so in this particular case, we are going to first identify which one is the main scale and which one is the vernier scale. So I can see 5 and I can see 6, and between these two I have about 10 equal divisions. Then it continues, okay, meaning that there are more than 10 divisions there or 10 markings. So this the top part, this part becomes my main scale. Okay, and this part I can see this is the 0 mark. From 0 I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10. All right. However, I don't know what happened. We still have markings there, which usually for that, people will become maybe confused that which one. However, you don't need these extra markings. You just need these 10 markings. All right. So you can even see the other clue for the main scale is that it is clearly labeled centimeters. Okay, centimeters. So this is 5 centimeters, 6 centimeters, 7 centimeters, 8 centimeters, 9 centimeters. While on the vernier scale, there is nothing labeled as centimeters or millimeters. So this will be my vernier scale. So this is my vernier scale. So we've identified those. Now we get to the actual thing. So the first thing you do is you get the reading on the main scale. Get the reading on the main scale. How do we get the reading on the main scale? Allow me to zoom in. So how do we get the reading on the main scale? So to get the reading on the main scale, what we need to do is go to the 0 mark on your vernier scale. Go to the 0 mark on the vernier scale, and this is my 0 mark. This is the 0 mark. Draw a line going through, cutting through the main scale. So I draw a line there, cutting through the main scale. Now, okay, so I draw a line cutting through the main scale. So I'll draw a line like that. This is too big. All right. So I'll draw a line. So this is my line, okay, cutting through the main scale. Now, if you look at your main scale, there is this part where the number increases. So we have 6, okay? We have 6, and on the other side, we have 5. Now, the 0 mark on the vernier scale is between 5 and 6. So because it is before 6, it means it has not yet reached 6 centimeters. It means that it is still 5 somewhere between 5. So it's 5 point something centimeters. So when you do that, get the mark that is closer to the smaller number, not the mark closer to the big number. And which mark are we talking about? We are talking about this mark. What does this mark represent? So we are going to start from 5. This is 5 and this is 6. There are 10 equal divisions. So this is 5, 5.1, 5.2, 5.3, 5.4, 5.5, 5.6, 5.7, 5.8, 5.9, then 6. So this mark represents 5.3. So this mark represents 5.3. So we are going to write 5.3, okay? We are going to write 5.3 as our main scale reading. So on the main scale, we have 5.3. These are centimeters. Now, for me, I advise we put a 0, okay? The 0 there after the 3, the 0 there, it is just to allow us to add easily. So I usually say write 5.30, okay? These are centimeters. So write 5.30. Then vernier scale. We now look for the vernier scale. So for the vernier scale, what we are going to do is search for a mark on the vernier scale that coincides completely with a mark on the main scale, okay? However, when I'm teaching in class, I usually make a joke over this, and I say, look for a mark that is kissing another mark on the main scale, all right? It may not sound appropriate to certain individuals, but at least it helps. So we are looking for a mark that completely aligns itself with another mark on the main scale. So the mark that completely aligns itself is this mark. Is this mark. This mark completely aligns itself with this mark on the main scale. So what does this mark represent? So we've got 0, 1, 2, 3. This is 3. So it's mark number 3. Okay? It's mark number 3. So people will say, okay, if you find it's mark number 3 that is coinciding with a mark, so what you do is you say 3 multiplied by 0.01 centimeters, okay? 3 times 0.01 centimeters, then it will give us 0.03 centimeters. What is 0.01? 0.01 is the accuracy, of the vernier caliper. That is the reason why we multiply by that. However, for such cases, or if you're just taking readings, the multiplication part really takes time. So for me, what I advise is just say under the whole number here, just write 0, then put a point, and under the 3 you already have a number there, put another 0, then get your reading there, which is 3, and place it there. So the 3 will coincide with the 0 on top. Okay, the only time that this will not happen is when it is mark number 10, which is completely coinciding. And when mark number 10 coincide, it means that we'll have 0.10. Okay, I hope that is clear. So when we multiply 3 times 0.01, it will still give us 0.03 centimeters, which is the same as when we just write 0.0, then the reading of the mark. So it's just one and the same. All right. Okay. So after we've done that, then we are going to add. We are going to add this. So we are going to have 0 plus 3 is 3. 3 plus 0 is 3. Then our decimal point, 5 plus 0 is 5. So it's basically 5.33 centimeters. Don't forget, it's centimeters. So when you now write your answer there, it is going to be 5.33 centimeters. Now, take note of one thing. Take note of this thing here. It's saying what? It's saying 2 marks, meaning that you need to show somewhere how you got to 5.33. You need to show somewhere how you got to 5.33. And where have we shown? We've shown here. This is the working, showing that we did not just dream about the number, but we actually used logical thinking, and the logical thinking has been shown, the process has been shown how we got to 5.33. All right, let's move on. The next part is saying convert the readings in A above to meters. Convert the readings in A above to meters. Convert the readings in A above to meters. This one is relatively easy. Again, it may be difficult for others. Remember, we are in grade 10. We are taught about prefixes. We are taught about prefixes. Okay. Now, what is a prefix? A prefix is a symbol. Okay. That is placed before a symbol of a unit. And it is used to represent a multiple of 10. All right. And the prefix that is in our measurement in A it's a C for centi. Okay, for centi. So what does centi means? Centi means, so C means centi. Okay, and what does this represent? It represents times 10 to the power negative 2. Times 10 to the power negative 2. Times 10 to the power negative 2. So, if it is times 10 to the power negative 2, it therefore means that 5.33 centimeters can also be written as 5.33 times 10 to the power negative 2 meters. The symbol for the unit remains. And what does times 10 to the power negative 2 means? It means that the decimal point should move 2 times in front. So if the decimal point moves 2 times in front, what we are going to have, 0.0533 meters. So this is 5.33 centimeters. It's 0.0533 centimeters. So the answer there now becomes 0.0533 meters. All right. Now, for others, this may not come out very good. So allow me to take another different approach to the same. Okay? Will allow me to take a different approach to the same problem. Okay? Now, the approach I'm going to take is the one that most people actually use, conversion of centimeters to meters. Okay? Now, conversion of centimeters to meters, we will have 1 meter is equal to 100 centimeters, right? Then this we are changing. So x is equal to 5.33 centimeters. So we are going to cross multiply. When we cross multiply, we'll have 1 meter multiplied by 5.33 centimeters is equal to 100 centimeters multiplied by x. So we are going to divide both sides by 100 centimeters. Both sides by 100 centimeters. So the 100 centimeter this side goes and this side it goes. So the centimeter here down goes and the centimeter on top goes. So what we remain with is the only unit is a meter. So we now say 1 meter times 5.33. We are going to have, so x will now be equal to 5.33 meters, 5.33 meters divided by 100. What is 5.33 divided by 100? It is going to give us 0.0533 meters. Okay, it is going to give us 0.533 meters, which is the same as before. So the reading there is still going to be 0.0533. Okay. Meters. So 0.533 meters, which is one and the same. However, you've taken more time, okay, and you're showing and everything. Time in an exam is usually very precious, and you want to preserve as much of it as possible. So that is that. So let's proceed to B2. Write the reading in B1 in standard notation. So now you can see that the earlier method actually even takes care of B2. So they now want it in standard notation. So in standard notation, we are going to move this decimal point until we reach a number that is between 1 and that is greater than 1 but less than 10. Then have it as a multiple of 10. So this one, we have the decimal point moving 2 times, which is 1, 2. Okay, it will move going this side 2 times. So, and it lands between 5 and 3. So what we're going to have is we're going to have 5.33 times 10. How many times did it move? It moves 2 times, times 10 to the power 2 meters. So this is how we write in standard notation or scientific notation. They may say standard notation or they may say scientific notation. It is one and the same thing. This number is less than 10, but it's greater than 1. Okay, so it's less than 10, but greater than 1. So I'm basically referring to just this number, not the whole number. So that is that. So we've written that in standard notation. Then we go to B3. B3. How many significant figures does the vernier caliper reading in meters have? How many significant figures does the vernier calipers reading in meters have? So we have where is reading in meters? It's there. When counting the number of significant figures, there are certain rules that actually apply. And the rules are basically just to deal with zeros. Okay? Zeros can only be significant if, one, they are in a decimal number. Okay? Two, okay, if they're in a decimal number, that is when in a decimal number, zeros can only be significant, one, if they are trailing. What do I mean by trailing? If they are at the far end of a number. Let's take, for example, we have 0.02, okay? And we have 0.20, okay? Yeah, so these are two different situations. This 0 here is at the tail of 2. So it is a trailing 0. It is a trailing, it is at the tail. And when a 0 is at the tail and there is a decimal point, you can vividly see the decimal point, then this 0 becomes significant. However, if the 0 is in front of the non-zero number, which is the 2, then it is insignificant. The 0 is not significant. So then the second is, if zeros are between two non-zero numbers, they are significant. Let's take, for example, 202. Okay, 0.202. The 0 in front is not significant, but the 0 between the twos is significant because it is between two non-zero numbers. Okay, so that is these are the times when 0 is significant. For a number that is not a decimal number, zeros between non-zero numbers are significant. So for such a case, it applies for decimal numbers and non-decimal numbers. For this one, it only applies for decimal numbers. So let's look at our reading. It's 0.0533. So there are two zeros in front of the 5. All of them are not significant. These two zeros are not significant. Unless if we had a 0 after the last 3, it would have been significant. So the only numbers that are significant are the non-zero numbers, which are 5, 3, and 3. So we've got 5, 3, and 3, which in total, the number of digits which are significant or which are important are 3. And these are 5, 3, and 3. So we have 3 significant figures. So 3 significant figures. So we've got 3 significant figures. 3 significant figures. So This brings us to the end of this video. If you've enjoyed the video, give it a thumbs up. If you're new to the channel, don't forget to subscribe and hit the notification button. Thank you very much.